Today in this session we will be studying about turbidity. Turbidity is the measure of cloudiness or haziness of water caused by suspended particles such as clay, silt, divided organic matter or other microscopic organisms. These suspended particles reduces the transparency of water. Turbidity is measure of cloudiness or haziness of water caused by suspended particles such as clay, silt, finely divided organic matter and other microscopic organisms. These particles scatter and absorb light, reducing the transparency of water. We can see the more the suspended particles are available, the more the reduced transparency of water. The IS code for measuring the turbidity is IS 3025 part 10. In this principle and method for the measuring the turbidity is given. For the drinking water, acceptable limit is 1 NTU nephelometric turbidity unit. When the alternate source is not available, it can be up to 5 NTU. The principle of the nephelometric method is we take the standard sample, measure the temperature of it, then in comparison with that, we take the sample from the field and measure the gravity. It is a comparison method. Principal nephelometric method. The method is based on comparison of the intensity of light scattered by sample with that scattered by standard difference suspension under identical condition. When the incident light passes through the sample, it scattered light in all the directions. The light which is scattered in the 90-degree to the incident light is measured by the photoelectric diode and recorded as the turbidity of the water. The most important part is of knowing the specification of the turbidimeter. In nephelometric measurement method, the specification of the instrument is like this. It should be type, bench type, range 0 to 1000 NTU, principle of operation nephelometric, accuracy for 0 to 500 NTU, plus minus 2% of reading. For 501 to 1000 NTU, it is 5 plus minus 3% of the reading. Response time less than 6 second, detector photodiode, light source infrared emitting diode, and the display LED is uh, display is LED. So all this specifications should be known to engineer. It is given in 3025. This is the instrument to be used for the measuring turbidity. There are many other type of instruments available, but for the measuring in the laboratory, it is 3025 nephelometric method of recording the turbidity. Then sampling is very important. If water is sampled properly, then only it will give the proper result. The IS 3025 part 1 is in that sampling method is given. We should take the water uh, as described in the IS 3025, preferably from the running water or from mid of the sampled water should be true representative. Then within 24 hours, we should find out what is the in the test what is the turbidity of that water. If not possible, then we store it cool and dark place at 25 degree plus minus 3 degree centigrade, and anyhow we should measure it within the 24 hours. So first step is to collect the water, then second step to level it properly, which if we are taking 5 to 6 sample from the same source, then we should level the time and the ID number of that. Then we should store cool and dark place at 25 degree plus minus 3 degree centigrade. And anyhow, it should be tested before passing the 24 hour. But when we are storing for the test in the cool and dark place, it should be brought to the room temperature before testing. So this is how the test method is given step by step. We should not vigorously uh, shake the sample, but we should shake before testing. So here we need to prepare first the standard sample. In standard sample, we take STMA, hexamethylene tetramine solution, and we prepare hydrogen sulfate solution. To prepare the hexamethylene STM, HMTA, hexamethylene tetramine solution, the chemical formula is CS2 6N4. We take 10 gram of HMTA, mix in the distilled water, stir it properly, then we make 100 ml of it, 100 ml of it. That solution will be ready for the test hexamethylene tetramine solution will be ready. Means in 100 ml of the distilled water, we prepare the hexamethylene tetramine solution, and then hydrogen sulfate solution. The chemical is NH2, NH2, H2SO4. We take 1 gram of it. Again, in the distilled water, we stir it properly. Then we make it to 100 ml, and then this is ready hydrogen sulfate solution. To prepare the Formazin means combined solution of hexamethylene tetramine and hydrogen sulfate solution, that is standard solution for measuring the calibrating the instrument. We take 5 ml of HMTA, hexamethylene tetramine solution, and 5 ml of hydrogen sulfate solution in a beaker. Keep it for 24 hours at the room temperature, that is 25 degree plus minus 3 degrees centigrade. Then again we add the distilled water to make 100 ml. Our this homogeneous solution will be ready. Then we should store, and the gravity of this solution will be 400 NTU. This standard solution will have gravity of 400 NTU. This is standard solution we prepare for calibration. From this 400 NTU, we make 40 NTU, 20 NTU, 10 NTU for calibrating and standardizing our equipment. So if we take 10 ml of this 400 NTU solution, and again take it to make it 100 ml with the distilled water, so ready solution will be of 40 NTU. Means we have taken 10 ml of 10 ml of 400 NTU and mixed with 100 ml of distilled water. So it will be of, the solution will be of 40 NTU. Likewise, we prepare for 10, 5 to 1 NTU for the calibrating our instrument. This should not be kept for more than 1 month. For 1 month it will be okay. Or if we are not preparing in the laboratory, we can directly purchase this gravity standard solution of 4000 NTU, 400 NTU, 10 into these are all available. We can procure for standardization from the market, from the chemist. We can procure and keep it in laboratory. Before testing, we should standardize with this standard solution our equipment. With that, again we can prepare 40 NTU, 20 NTU, 1 NTU as required. So for more accuracy calibration, we go for the 10 NTU. So we can take only uh, 5 ml of this 400 NTU, or 2.5 ml of 400 NTU divided by 100. So we can prepare 10 NTU standard solution. So likewise, we prepare the standard solution. Once standard solution is available, we calibrate our Nephelometer, Turbidimeter with the standard solution 0, 10, 20, 40, 100. In the laboratory, we go for 40 NTU. Fill a clean sample tube with the calibrated standard. Then clean it properly. We should have the hand gloves also, and then we should clean all around whatever some impression is there. Wipe the outside of tube with the lint-free tissue of remove fingerprints and water droplets. Then insert the tube into the nephelometer and record the reading. Once we insert it, we record the reading. It has come 20.1. So our this nephelometer gravity meter is standardized with the 20 NTU, because plus minus 2% is allowable. So it is with the 20.1 NTU it has been standardized. So we record the reading for the 10 NTU how much it has come. For 20 it has come 2.1 plus minus 0.1 ज़्यादा है. Then 40, then for 100. We standardize by calibrating our equipment with the standard solution. Once a standard solution, the equipment is standardized, we go for with the our sample, water sample, which we procure from the field. Gently shake the sample to informally disperse suspended particles. This is for the gravity less than 40 NTU. This procedure is for gravity for less than 40 NTU. Pour the sample into a clean gravity cell. Pour the sample into clean gravity cell. fill the cell up to the marked level. Fill the sample up to the marked level. Remove air bubble by gently tapping the cell. If any air bubble is there, we should remove it, and then wipe the outside surface with lint-free tissues. Outside surface also carefully should be cleaned, and then we place in the cell in nephelometer with proper alignment. With the proper alignment, we should place, and then we should record the reading and allow the reading to stabilize. Now for this solution it has come 0.68. We should record this 0.68 in our laboratory records. For the sample ID etc. Sample ID W01, gravity of this sample is 0.68 with the standardized Nephelometer. If gravity of water is greater than 40 NQ, then we should take the sample. Then we should take the like 20 ml of sample, and then we add 80 ml to make 100 ml and measure the same with the same procedure by cleaning and placing it properly. The gravity of this, if it has come say 32 NTU, then we should up the added with uh, uh, diluted sample, then we should regard this 32 into, then we interpolate with the formula given in the IS 3025. Sample was 20 ml, diluted to 100 ml, diluted to 100 ml, diluted to 100 ml. So diluted sample is 100 ml, it is containing 20 ml original sample, 80 ml distilled water. So it has become 100 ml, and combined the measured gravity is 32, so 32 into 100 divided by 5 will be the uh, original gravity of the sample, that is 32 5 160 NTU. That final volume, it is original gravity of sample will be the diluted into 100 divided by 5. So we measure the gravity if it is more than 40 NTU by diluting sample, regarding the dilution with how much distilled water we have added, adding it, multiplying with the obtained gravity of that diluted sample divided by the factor, that is 100. This 100 by 20 means total has become 100 ml, and then original sample was 20, so with 5 multiply with this dilution factor, we get the original sample gravity. So with this, how to measure gravity of the sampled water we have completed. Thank you.